Hello, and welcome to this ABB Enterprise Software presentation, Energy Market Implications of California Senate Bill 350. And now I give you today's speakers from ABB, Ardal Kara, Industry Solutions Executive, and Eric Skadden, Advisory Consultant.
Thank you very much, Dana. Next slide, please. Next slide, please. And thank you very much for joining our webcast today. And this is our legal disclaimer. It's mainly telling that ABB and the presenters are not responsible for any information and errors in this document. Next, please. Today, we will cover several topics today, and we will start with the overview of ABB Energy Portfolio Management Group. Then we will provide a background on the California SB 350. Then we will talk about our modeling assumptions and talk about the scenario description and results that will be covering the effects of the California SB 350. And then we will talk about the new integrated resource planning guidelines, and we will talk about the ABB Solutions and Services conclusion, and we will have a questions and answers session at the very end. Next, please. Next, please. ABB is one of the largest companies in the power industry with around 140,000 employees. It's a global company with offices in more than 100 countries, and it has an annual revenue around $40 billion. ABB was formed with the merger of Swiss company BBC and the Swedish company SAR. Both of these companies were founded in the late 19th century and had a long tradition of engineering and innovation culture. ABB today continues with this engineering and innovation culture. Next, please. ABB has four main divisions: electrification products, power grids, discrete automation and motion, and process automation. ABB produces both hardware and software solutions. ABB Enterprise Software is part of the Power Grid and Grid Automation Group and represents the software side of ABB. ABB Enterprise Software has around 2,000 employees and has a wide variety of products used in the fields, plants, control centers, operation centers, and the corporate headquarters. Next, please. EPM Group is under the ABB Enterprise Software, and EPM has around 200 employees. And EPM products are generally used for corporate strategy and planning purposes. EPM has three groups: a data intelligence group, a software group, and an advisory services group. These three groups work together to provide high-quality products and services. EPM introduced the very first commercial optimization software for the utilities ProMod in 1975, and in December 2015 we celebrated the 40th birthday of the product. EPM is the market leader in several software product categories. Our clients make around $5 billion investment decisions using our products and services. Now, Eric Skadden will provide the background for the California SB 350 and its market implications.
Yeah, thank you, Ardal. Hi, this is Eric Skadden. Let's start with discussing the difference between AB 32 and SB 350. First of all, the AB 32 is referred to as the Global Warming Solutions Act of 2006, and that was enacted during the Schwarzenegger administration, which set as a goal a 33% of energy from renewable sources must be the component of energy that load-serving entities supply their customers. Now, SB 350, which was passed into law last year, October, by Jerry Brown, is a more aggressive, has at its core a more aggressive renewable portfolio standard, which has as a state goal the requirement of those same load-serving entities to serve 50% of their electricity from renewable sources by 2030. Now, since 2006, California has made strides in achieving intermediate milestones. For example, to get to where we are now with the SB 350 mandated targets. Between 2007 and 2015, California's total renewable energy generation more than doubled from 12% to nearly 25% of the state's retail sales. And California's IOUs are already on pace to surpass the 2020 target of 33%. So this SB 350 new mandated target of 50% is a target that looks to be a reasonable stretch goal from where we are now, and that the time span available to achieve that those new quantities into the market. Now, one additional note that I want to point out is that it should be noted that since the passage of SB 350, PG&E, one of the three IOUs in the state of California, has announced it will voluntarily commit to a 55% RPS target by 2031. So that tells you that they're on board with SB 350. Now, some of the other aspects of SB 350 include the fact that we need to account for the renewable intermittency, and we need to integrate all of these new renewables into the market. So one of the components of SB 350 is the expansion of the California ISO's footprint to create a west-wide single footprint of an ISO operator. And that's something that is currently being scoped and has a goal of becoming more tangible this coming year, 2017. Next, please. Another aspect of SB 350 is the introduction of a statewide requirement to resource planning, ensuring the goal of achieving a 40% reduction in greenhouse gas emissions below 1990 levels by 2030. And so the California Public Utility Commission has been tasked to guide the resource decisions that LSCs will need to procure to meet the emissions reduction targets here in greenhouse gases, but also with coordinating the goal of greenhouse gas emissions reductions around all of the other existing energy policy goals that are in place already. For example, energy efficiency, demand response, and the renewable portfolio standards I just mentioned. So we have the load-serving entities are classified as either POUs, publicly owned utilities, or IOUs, and the POUs will be under the jurisdiction of the CEC and the IOUs under the PUC. CEC being California Energy Commission and PUC being Public Utility Commission. So we've got 16 POUs, and we have 3 IOUs, and then we've got a initial year 2017 as the initial year required to begin the IRP process as outlined in the California SB 350 legislation. Next, please. Okay, now I'm going to introduce the power reference case, which is a product we offer that is going to be utilized here in this presentation to help us understand the implications of SB 350 relative to AB 32. And so I want to introduce the product here in the next few slides and then get into some analytics about the impacts of SB 350. So the reference case really is it's built around a model of a lot of available data. We heavily rely on Velocity Suite product, which is it's a sister product within ABB for load forecast, generating unit characteristics, new entrants, and proposed retirements. We also supply other data such as fuel products and emissions regulations. So this data gets assembled and we feed the data through an integrated model that is used to forecast, accounting for interdependencies between commodities such as electricity, gas, and coal to maintain reliability, to accurately account for renewable portfolio standard mandates, not just in California, but WECC-wide and across North America and other jurisdictions. And as a product, we have, as a final product of a product which is the electric price forecast and capacity price forecast, that is an outcome of PROMOD, which is a production cost simulation engine that actually forecasts the energy prices. So next slide, please. So the reference case is actually a product that is 5 different products. It's a analysis of WECC, that's one of the products. Then we have the Midwest. We have ERCOT as a 3rd product. Then we have the Southeast as the 4th, and then the Northeast as the 5th. For purposes of this presentation, we're going to be focusing on the WECC product, and in particular the markets that we model in California, which span the state from the Northern California portion to the Southern California portion, with San Diego broken out by itself, and we've got LADWP there, and California SCE, which is Southern California Edison, and the northern tip of Baja. Okay, next slide. So what is the analytical aspects that the reference case covers? Well, at the core is a hourly electric energy and annual capacity price forecast. And then in addition to that, we have load growth, and we have an expectation of new natural gas capacity requirements to meet the load growth. And so we have inherent in the product as an output the annual capacity additions. We have both announced and age-based retirements and retrofits modeled, and we also have a monthly natural gas price forecast that pertains to Henry Hub, but also 30 liquid market centers across North America. And then we've got a coal price forecast component, and then for reliability purposes, we forecast reserve margins and the relative abundance of supply against demand. And then we provide a resource mix on the 73 markets and how diversified those markets are with respect to fossil fuel and non-fossil resources. For all regions, the reference case has a REC price forecast. We have a California REC forecast, and then we have other REC forecasts, for example, an ERCOT REC forecast. And then a companion product to the reference case is a 24-month short-term forecast, which is just refreshing the initial 2 years of the long-term 25-year forecast. Next slide, please. Now, what I want to do is transition here to some of the specific assumptions in the WECC Spring 2016 Power Reference Case. That was the most recent release as of May of this year. Now, the first bullet here on the supply assumptions aspect of the slide, it says that Diablo Canyon is active with a 60-year operating life. Now, we know that since May, at the point in time this forecast was released, we know that PG&E has announced that Diablo Canyon would be retiring at the end of its NRC license, which is going to be 2024 for Unit 1 and 2025 for Unit 2. But at the time, as of May, we didn't know that. So we have Diablo Canyon active. And some other supply assumptions here relate to the fact that recently Alberta has announced that it is going to phase out all of its coal capacity by 2030 as part of the Alberta Climate Leadership Initiative. And likewise, we've had Oregon come out with legislation that also, by 2030, essentially disallows the LSEs in the state to serve its retail loads the coal electric generation from out of state. And that law is the Clean Electricity and Coal Transition Plan. So those are the key kind of takeaways on the supply side, in addition to the fact that we have the SB 350 50% RPS standard in the forecast. Now, on the demand side, just real quick here, we have the California Energy Commission's most recent load forecast, which is the one that was published in January of 2016. It's diverse volume 2, and it's the mid-demand baseline case adjusted by mid-AAEE, which is the additional achievable energy savings. One of the things that is striking about the forecast is that the actual loads from 2016 over the next 10-year forecast period inherent in the CEC load forecast actually drops. The non-coincident peak actually falls by about 2,500 megawatts across those 10 years. Next slide, please. Now, with that prior slide discussing the base case assumptions of that spring 2016 WECC reference case release, now I want to talk about, well, with the new information we have on Diablo Canyon and the fact that SB 350 is producing or has at its core the 50% RPS requirement, let's do some what-ifs to help us understand how both the new information on Diablo Canyon and the new information we have from SB 350 really is affecting the emissions of greenhouse gases in the state of California and the electric prices in the state of California. So next slide, please. The slide here is just to quickly help us understand the Diablo Canyon facility. It's located in the transmission zone, one of the modeled markets in California called California's ZP26. And it's California's last operating nuclear facility. Now remember that the San Onofre nuclear generating station permanently retired, that is, in 2013, even though it had been operating in the prior year before that, but it permanently retired in 2013. So yes, Diablo is, in fact, the last operating nuclear facility in the state. And by November of 2024, Unit 1 will be retired, and the following year, August, Unit 2 will be retired in 2025. And so, in combination, that's 2,300 megawatts of capacity that we're going to lose on the supply side. So we would expect that we're going to have an uplift in the wholesale electric prices that we're going to be forecasting in the future. And so I want to gauge that degree of change here in the scenario. Next slide, please. So what I've done is I've put together these various scenarios, and I want to show some results here in the next slide, but just to quickly describe the scenarios, essentially what we have here is we have case 1 being the base case. Okay, that's that new SB 350 and the 50% RPS requirement and Diablo Act. Remember, we didn't know as of May Diablo was retiring. Now, case 2 is let's retire that 2,300 megawatts, but let's see, okay, in isolation, what's the implication of Diablo Canyon retiring to carbon emissions in the state and electric prices. And then case 3, well, wait a second, what happens if we roll back to AB 32 and the 33% RPS? And had Diablo active, what kind of change do we get relative to, in case 3 relative to case 2? And then finally, case 4, well, what happens if we just eliminated all of the supply from Diablo and reverted to the lower standards in AB 32 and the lower penetration of renewables? Well, what would that do to carbon emissions, and what would that do to the electric prices? So next slide, please. So let's talk about the results of those cases. Next slide, please. So here is a slide that displays the California carbon emissions amounts by year post from today to the year 2030. And I wanted to zero in just on that span through 2030, which is the year that we have to achieve that goal of SB 350 of the 50% RPS standard. So really what we're seeing here is the CO2 emissions bottom out in 2023. See, that's the year before Diablo Unit 1 retires. And so even with the continuation of a carbon tax, that's the carbon tax administered by CARB, California Air Resource Board, and the continued renewable build-outs in the various the 2 RPS standards, we're not going to get enough to displace the loss of Diablo Canyon. That's what the main takeaway of this slide is. And strategies post-2025 will need to address the loss of base load zero emissions resource such as Diablo, or find other technological improvements in such as storage to address that loss of that base load zero emissions unit. So real quick, we're getting a bump up in carbon emissions in an amount of about 7.5 million tons, with in the 2 extremes going from Diablo plus RPS 50 to the other opposite extreme of no Diablo and that softer RPS requirement of 33% as stipulated by AB 32. So now we have these 2 intermediate cases where we see that, okay, which one is worse in terms of reversing our goal of reducing carbon emissions and greenhouse gases? Which one of the 2 is worse? It's actually worse, the retirement of Diablo relative to having Diablo and having that softer RPS. And so what we're saying here is that 2,300 megawatts of base load is not getting replaced by that extra renewables that we're seeing with the RPS of 50% inherent by the new legislation of SB 350. Okay, so the next slide, please. Now, the last slide on the results is this quick takeaway on the electric prices. Now, here I want to point out right away that the lines here, all 4 lines are following the trajectory of our natural gas price forecast. And so each line is going up, but the degree of difference is dictated by whether we have Diablo or what RPS standard. Now, what else I want to point out here is that that the reason why it's increasing with our natural gas price forecast is because the fuel on the the generating facility that's the marginal unit that serves load the majority of the time, in excess of 90% of the time, is a natural gas-fired generating facility. So the fuel cost pass-through is following to the electric prices following the fuel cost to the generator. Now, at the extreme, we're getting about a $9 bump up in the electric price, dollars per megawatt hour. Now, this is a statewide average annual number. So I'm not looking at Northern California or Southern California. I'm just looking at a simplified assumption, just in aggregate overall. We should see or experience, we would have experienced in our forecast from May, the spring release, we would have approximately experienced about a $9 uplift, assuming we had rolled back to AB 32, the 33%, and we lost Diablo. That's post, that $9 difference is post 2025. Now, we have, again, those two intermediate cases, and we see that the two cases are sandwiched in between the base case and the other extreme. And we're seeing that we're getting about a $5 bump up because of rolling back from AB or SB 350 to AB 32, and we're getting a smaller bump up of only about $2 by the loss of Diablo. So you can see that here on the electric price side, as opposed to the carbon price side, the loss to Diablo is actually not as bad in electric price consequences as it was with the carbon emissions consequences. So now what I want to do is allow Erdl to continue with some other aspects of SB 350.
Thank you, Eric. And now we will talk about the new integrated resource planning guidelines. Next slide, please. First of all, let's answer the question. The main question is, why did the SB 350 require a formal IRP process now? So the main reason now is that the current procurement planning process has several individual proceedings, and each proceeding has a different focus, and each proceeding uses a different cost optimization methodology. And for example, like energy efficiency and demand response programs focus on procurement of resources that meet a minimum cost effectiveness threshold. On the other hand, long-term procurement plans, for example, focus on system reliability and procurement of the least cost resources. And RPS programs focus on then the procurement of least cost best fit renewables. And it's a well-known fact now that California is leading the renewable revolution here, and now large amounts of renewable generation in the system requires, I think, really careful long-term planning due to potential long-term and short-term generation and grid reliability issues resulting from the intermittence of the renewable generation. I mean, we are all aware of the CAISO's duck curve, and it's really looking forward-looking, and it's the main reason is that in the long term we don't want to have any big reliability issues or like local congestion issues or any other issues. That's why IRP, in that sense, is preparing the state for like its emission and environmental goals. Considering all these proceedings in an IRP process will help California obtain optimal resource planning for the state and obtain its greenhouse gas emission targets. Next slide, please. Now, let's talk about the integrated resource plan, or let's call it IRP, and it's similar to the current long-term procurement plan system. But there are some differences, and I'll talk about them later. So the IRPs will have planning horizons longer than 10 years because they will go towards 2030 or later. And IRPs will be filed at least once every 5 years. And given the emissions and renewable targets and all moving, everything moving together, one can expect probably IRPs will be filed every 3 years or so. And the IRPs will optimize supply and demand side resources and subject to system reliability, GHG emission, greenhouse gas emission reduction targets, and cost effectiveness constraints. Next slide, please. So IRP is a combination of several steps, including different regulatory agencies, and it uses inputs from various resources. California also provides the transmission and generation inputs, and California Energy Commission provides the load forecast, and individual utilities preparing the IRPs will provide their own data. As mentioned in the previous slide, and now the optimization methodology used by the IRP will be subject to greenhouse gas emission constraints, and then we will need the individual utility will need to minimize the system costs given the several constraints, especially GHG target with the binding constraint. This wasn't really the case in the LTTPs, and now IRP process now needs to use a more complicated analytical model. And I'm almost certain that each utility needs to use a software solution to get a least cost optimal IRP resource mixture. And the IRPs will produce these optimal resource mixtures, and that will comply with those optimal resource mixtures will comply with the individual resource programs such as the energy efficiency, demand response, distributed generation, energy storage, etc. And the IRPs will also be used for the rate design purposes. So the moral of the story is we need, compared to LTPP, IRP is a more complicated process, and it will require a new analytical model for optimization. Next slide, please. IRP is a long process with several steps involved, and the ABB Advisors have been providing consulting services for clients involved in the IRP processes over 30 years, and given our extensive experience over these years, approximate allocation of the effort for a typical IRP process is summarized in this slide. So there are several steps, but we categorize them into 8 steps, and the first step is the review of the regulatory and utility planning policies. And in my opinion, the following 2 steps are the most important steps in the process: developing data assumptions and developing demand side and supply side alternatives, as well as the alternative scenarios. So the reason is that when you set up, once you start this and make your assumptions right, and you will use them, and if you make your assumptions right, that will be very beneficial in the future, because in the next step something doesn't go right because your assumptions were wrong or there was a problem with your data or something. It's really hard to go back and redo these steps in the process. So the first 2 steps, developing data assumptions and alternatives and getting the right data, using the right good forecasting, and using the right inputs is the critical step in the IRP process. And the major inputs are needed are the environmental regulations and policies, your discount, interest rates, inflation rates, load and generator data, fuel, power, and emission prices, and price forecast for fuel, power, and emissions. And your generation expansion options, different technologies will be important, and you will need the capital cost for these technology options, and also you have to focus on your demand side options, DSM, energy efficiency, etc. And California has several other proceedings, so you have to really consider the electric vehicles, their impact on the load, and you have to consider the load shape affected by the distributed generation, etc. So it's a complicated process, and setting it right is a critical step. And the next step is the portfolio optimization, meaning that you create your mathematical economic model and you run it in a software system. Then you do your risk assessment. Risk assessment means you run different scenarios and sensitivities, and also you do stochastic runs and stochastic analysis. And this step is becoming very important because now large amounts of renewable generation adds definitely a lot of uncertainty to the system, and a lot of uncertainty to the economics of the system too. So this step is also, I think, also pretty critical. Then operation analysis is then now the operations and the transmission groups from within an organization look and analyze the feasibility of these long-term plans coming from the IRP. And then after this, everything is complete, then it comes up with the recommended action plan, and the latest step is the documentation and then regulatory support. And this is like basically writing the report and submitting the plan to the regulators and do the testimonies and hearing. Sometimes this very last step also takes very long because there may be some back and forth communication, and certain things may not necessarily be accepted by the regulatory authorities, and the certain things then the utility may have to rewrite certain sections or even redo modeling of the certain sections. Next slide, please. Then now we'll talk about how we can help in the IRP process. Next slide, please. Now, IRP is an integrated system, right? And it's a required IRP is an integrated system, and it's a required integrated process, and therefore IRP requires a truly integrated solution. And the ABB E7 platform is an integrated platform using a common user interface and a common database, and which is using a Microsoft SQL Server database. And this, again, as I would like to emphasize, this is a truly integrated solution, and we call it E7. And the E7 has three models. The first one is the capacity expansion model. And capacity expansion model produces long-term generation expansion plans. And using future supply and demand options, again, DSM programs, what are your future investment options, renewables, wind, solar, distributed generation, demand-side programs, what are the capital costs from all these? And you put the long-term reliability reserve margins, and you put emission and renewable regulations as constraints in the system. And capacity expansion comes up with the expansion plans for you. The most optimal expansion plan, given all these environmental regulatory constraints, as well as all the capital cost data related to the technologies and your generation cost of your generation fleet, all coming together, optimized. And it's already used by around like 50 clients in North America, and majority of the clients use it for their IRP efforts. And the next model is then the expansion plans. They will definitely have an effect on the market prices and maybe cause congestion in the transmission system. So to see these effects, then we get these expansion plans and use our ProMod, our fundamental market analysis software, and the ProMod produces zonal or nodal market prices and potential congestion points in the transmission system in the future. So again, we can see how the expansion plan will affect the market prices as well as the congestion in the system. So ProMod does that, and ProMod comes up with the market price forecast, and then you can look at also the potential congestion issues in the future. And then the power portfolio optimization model in E7 uses these market prices as well as expansion plan to do a very detailed chronological analysis of a utilities portfolio. It has also very sophisticated thermal and hydro modeling features. And it's used for both short-term and long-term analysis. And so therefore you can look at the impacts of your long-term plan in the short-term and long-term using this tool, and it has also very sophisticated stochastic analysis tool. So then the gas portfolio optimization is also a new tool we have, and it will be part of the integral part of the E7 system. And gas portfolio optimization is a natural gas portfolio planning tool, and it provides gas supply, portfolio optimization, contract sizing, and scenario analysis. So therefore, it will help the generators to optimally plan their natural gas purchase decisions. Next, please. Now, ABB also has the data intelligence group, and our data intelligence product is called Energy Velocity or Velocity Suite. And Energy Velocity has several data modules: power, fuels, transmission, weather, market operations, and trading. It also provides detailed generation and transmission data. So it has the historical load data as well as the load forecast from the ISOs or the other regulatory authorities. And it's providing also the historical and future power and fuel prices as well as emission prices. It's a cloud-based tool, and it's updated several times during the day. Then we use the energy velocity data to create our simulation-ready data for the WCC. Next, please. So we create the simulation-ready data for WCC area. Then the simulation-ready data can be used, again, all coming back to the E7 system, can be used in our software. As the name implies, it's a simulation-ready data. It's ready to run. So this, next, please. And one more click, please. So this entire system is using one common reporting system. We call it EPM reporting. EPM reporting will be able to will enable the user to compare your simulation results with the historical data. So you can also create custom reports out of, custom reports from your simulations as well as the real life data. So compare them together. It will really help a lot with the IRP process. Next, please. So we have the IRP services, which are provided by advisors. So we can write the entire report. That's one of the things. If it's required by one of our clients, we can write the entire report for the client, the IRP report. And we also provide strategic planning, IRP and RFP analysis, decision analysis, expert system and resource optimization modeling, scenario and sensitivity development. Next, please. Project development and management, process design and implementation, expert witness, third-party analysis, independent evaluation, and we can also process and review and evaluate the entire system, so like as a third-party analysis. Next, please. And this is also a group of advisory services we are providing. So we are providing market analysis as a service, and we have the providing asset valuation and market analysis services, regional, national forecast and analysis. We provide also nodal LMP forecasts, and as I mentioned, we have the simulation-ready data. Next, please. Next, please. And let's talk about the conclusions. First of all, we just wanted to show that the comparison of AB32 and 350 and and 350 brings a larger amounts of renewables to the table, and we want to see how it affects the prices as well as the emissions. And as we mentioned, the large amount of renewables definitely decrease decrease the CO2 emissions and decrease the prices. And it's a complicated process, and there are some other aspects of SB 350 we could not cover today. And one needs to understand all these to understand the entire picture. And the scenario results show the fossil fuel generation will continue to serve an important role as a reliable resource as energy policy in California. And then the SB 350 requires definitely more detailed IRP process, and as the final note, as ABB, we have years of experience and lots of tools, expertise, and products to help with the IRP process. This is the end of our presentations, and we can switch to the questions and answer section.
Okay, Erdal, so the first question that we had come in, how long do you think an IRP process will take from start to finish?
I think it usually takes at least a year, but California IRP process sounds more complicated than the, I think, general overall typical IRP process. So I think it will take probably around between 1 year and 2 years.
Yeah, this is Eric. I see a question that I'll answer. The question is, were the average California prices across all hours or on peak hours? And the answer to that question is that they were all hours. So it's a statewide annual all-hour average. Here's another question. The year 2030 between Diablo plus RPS 50 and Diablo retired plus RPS 50, what is the energy mix to replace Diablo? And the answer to that question is that it is natural gas-fired generation. Now, there's another component to that question. There's a statement here. PG&E stated the forecast shows Diablo not running as much by 2030. That's kind of a statement. My response to that is, well, it depends on what the natural gas price forecast is. If by 2030, if the gas prices forecast is low, yeah, the potential for Diablo to be relatively uneconomic and have a low capacity factor might continue, but it depends on how high the gas prices get and how competitive Diablo would be under that type of higher natural gas price view.
Just as a final note, this is our website, energymarketintel.com, which provides lots of free webcasts and lots of useful information about the global power industry.
Thank you for joining us today. This now concludes this presentation. The slides and recording of this presentation will be sent to all who registered via email. Thank you for joining us today and have a great day.